So now we're going to take the remainder theorem to its next logical step, and that gives us the factor theorem. Okay, so the factor theorem says if we have some polynomial p of x, and a polynomial p of x has a factor of x minus c if and only if p of c is equal to 0. Okay, and what that was really saying, given our previous previous video on the remainder theorem, is that if you divide p of x by x minus c, and you have no remainder, that means that you can cleanly divide the polynomial by that, and therefore it's a factor. And what this really means is if you have some, that means you can write p of x can be written as some other polynomial, ax to the whatever dot dot dot, okay, times x minus c. Okay, so that's really what we're saying here. Okay, I guess we could say it's n minus one, so it'll be a different a, but it'll be a degree lower polynomial, right? So that means we're able to then start to factor these polynomials this way. So now we have reduced this polynomial just ever so slightly. Let's see what this looks like in practice. Okay. So let's say we have p of x equals negative 2x to the third plus 5x squared minus 15. We want to see if x minus 3 is a factor, okay? So let's go ahead and do our synthetic division. So we're going to divide by 3 here, and let's line up our coefficients. So we have negative 2, we have 5, we don't have anything for x, so we put a 0 there, and then we have negative 15. Let's go ahead and bring down this negative 2. Negative 2 times 3 is negative 6. 5 plus negative 6 is negative 1. Times negative 3 is negative 3. 0 plus negative 3 is negative 3. And negative 3 times 3 is negative 9. And negative 9 plus negative 15 is negative 24. And since that means the remainder is not 0, therefore, that means that x minus 3 is not a factor. Okay? So therefore, you could eliminate that one. If you were trying to factor this polynomial and to write it as a product of binomials, then that means that x minus 3 is actually not a factor here. Okay? All right. So now let's look at q of x is equal to negative 2x to the third plus 5x squared minus 3x plus 18. And now we want to see if x minus 3, again, is a factor. So let's divide by 3 here. All right, so let's put our coefficients in. We have negative 2, we have 5, we have negative 3, and then we have 18. Let's bring down negative 2. Negative 2 times 3 is negative 6. Okay, let me get negative 1. So we get negative 3. Negative 3 plus negative 3 is negative 6. Negative 6 times 3 is negative 18. Plus 18 is 0. So since we have a remainder of 0, x minus 3 is a factor. Okay, it is a factor. Okay, but what this also means is that we can now write q of x as the following. We have the coefficients here for now a degree 2 polynomial, so we can write this as negative 2x squared minus x minus 6 times x minus 3. So we have now reduced this polynomial just a little bit. So now we could keep going. We could use now maybe the quadratic formula, or there's some more techniques we're going to look at later to continue to further reduce this polynomial to make it a product of binomials. Okay, so that's the real power of this here. We're not just randomly using this just to see random things. We're using this to see if we can reduce polynomials into their simplest form.